Okay, the next exercise is limit x approaches to infinity, and it is x plus a divided by x minus a raised to the power x. Okay, let y is equal to x plus a divided by x minus a raised to the power x. Taking natural log of y is equal to natural log of x plus a divided by x minus a raised to the power x, and this will be equal to x into natural log of x plus a divided by x minus a. The limit is obvious, it is x approaches to infinity. X approaches to infinity. Here the given limit is x approaches to infinity. Okay, so now I can take common, which is equal to x natural log of, if I take x common, it will be 1 plus a by x, and from here again take common x, 1 minus a by x. Okay, x is cancelled out with x, and this will be equal to, which is equal to x natural log of 1 plus a divided by x and 1 minus a divided by x. Here we set 1 over x is equal to z. Since x approaches to infinity, this implies that z approaches to 0. So we can write above z approaches to 0. The limit is obvious, x, I am not writing with it limit, it is obvious, z approaches to 0. So it is 1 plus 1, it is 1 plus az, 1 minus az. Okay, now we can write natural log of, so that means x is equal to 1 over z. So this, when we convert it into z, it will be 1 over z. Okay, so that means we can write this is equal to natural log of 1 plus z, 1 plus az, 1 plus az minus natural log of 1 minus az, and divided by z. The limit is z approaches to 0. So it is 0 divided by 0 form. 0 divided by 0 form. Since it is 0 divided by 0 form, that means we will apply the L'Hopital rule. It will be derivative of natural log of 1 plus az, it will be a divided by 1 plus az minus, and the derivative is minus will be plus, a divided by a minus az. divided by 1, which is equal to 2a, and after simplifying, and this is equal to 2a 1 minus a square z square. So when we put the limit a approaches to 0, z approaches to 0, we get 2a. Okay, and natural log of y is equal to 2a. Yeah, so limit, this implies y is equal to e raised to the power 2a. So what is y? The limit of y is x approaches to infinity, e raised to the power 2a. Okay, let me take a look at this question. The limit x approaches to 0 sine hyperbolic x divided by x 1 by x square. Okay, let y is equal to sine hyperbolic x divided by x. Okay, so to solve these questions, similarly as we have taken natural log in the previous questions, we will also take natural log of this question. And this question is similar to the previous question. What do you think, students? I should be left for this question for an exercise. You will solve this question, and if you have any kind of problem, then I will again upload the solution of these questions. I will again upload. Okay, but not all the steps, but some steps I am doing. So what are those steps that I am doing? Okay, see that the first step is simple, just like we take the natural log, that is natural log of sine hyperbolic x divided by x, and it is 1 by x square. The limit is, of course, as it is given x approaches to 0, by the property of log we will write 1 over x square before. Okay, then natural log of sine hyperbolic x divided by x. So this is equal to natural log of sine hyperbolic x, and is this is of course 0 divided by 0 form, 0 divided by 0 natural log of x, and So I can write it just like natural log of sine hyperbolic x minus natural log of x divided by x square. Since limit is x approaches to 0, so x approaches to 0, 0, and yeah, so this is 0 divided by 0 form. Infinity, yes, 0, natural log of sine hyperbolic x approaches 0, 0, natural log 0, okay, is infinity. So natural log of x, it means we will apply the L'Hopital rule. So the derivative of natural log of sine hyperbolic x is 1 over sine hyperbolic x, and the derivative of sine is cos hyperbolic x minus the derivative of x is 1 over x. The derivative of x square is 2x. Okay, now it is after taking the LCM, it is x, yes, we get the x cos hyperbolic x minus sine hyperbolic x, and this x will be after taking LCM, it will be 2x square, since LCM is x sine hyperbolic x, and when it will shift into the denominator, 2x square sine hyperbolic x, x approaches to 0. Okay, it is again 0 divided by 0 form. Since it is again 0 divided by 0 form, that means that what we will do in case of 0 divided by 0 form, we apply the L'Hopital rule, and the derivative of x is 1 cos hyperbolic x, okay, plus x sine hyperbolic x, and minus cos hyperbolic x into 4x sine hyperbolic x, okay, and plus 2x square cos hyperbolic x. It is again 0 divided by, so if cos hyperbolic is cancelled, again 0 divided by 0 form. Approximately all the questions have been done by me, and you will do a little more, not much more. Okay, again 0 divided by 0 form, so apply yeah, sine hyperbolic x. It will be yes, so derivative of x is 1. Okay, very simple. Next, only one step or two step. So I am telling you the answer is 1 by 6. So the remaining part left for an exercise. Okay, you will do it.